All right, today we're going to do lesson 3-6, which is lines in a coordinate plane. Our objective for today is to graph lines and write their equations in slope-intercept form and in point slope form. We're also going to be classifying lines as parallel or intersecting or coinciding. So first, for our point slope form and our slope intercept form, we're going to write those down here. So go ahead and move that on down. So our point slope form is this form right here. It is y minus y1 equals m parentheses x minus x1. Okay? So what these different things mean is m is your slope. So this right here is your slope. And your y1 and your x1 are a point on the line. So x1, y1 is a point on the line. Okay, so for example, let's write an example next to it. We have, let's do y minus 3 equals 2 parentheses x plus 4. So you'll notice that my first equation here has negatives here, it has a minus here and a minus here. So that means that my point on the line is not negative 3, it's just positive 3. And notice that this one has a plus 4, and you can think of this one as, so let's rewrite this as y minus 3 in parentheses equals 2 parentheses x minus a negative 4. So you'll see that what we did is we rewrote it so that the minuses here is the same as the minus here, and the minus here is the same as the minus here. So that helps us know what our point is. And so the trick to it is that whenever you're dealing with the point slope form, if you have a minus, it's always opposite. If you have a plus, it's always opposite. So my slope in this case is 2. So m equals 2. And the point is negative 4, positive 3. Okay? So we'll do an example, another example of it down here when we do this example down here when we graph it. Okay, so that's how I pull out the point and the slope from the point slope form. Okay? Slope-intercept form is more commonly used, y equals mx plus b. And what this is we have the slope again is m, just like it was up here. But this time, instead of having a point on the line, we are told what the y-intercept is, and that's what b is the y-intercept. Okay? So y-intercept is what b is. So let's do an example. Y equals 1/2 x plus 7. So that means that my slope, m, is 1/2. And my y-intercept equals 7. And y-intercept, remember, is where it crosses the y-axis. Now, vertical lines are always in the form x equals some number, and we'll do maybe a. So what that means is that it crosses the x-axis at A and is vertical. So for example, if we did x equals 5, then that means that it would cross the x-axis at 5 and it would go vertically up and down. That is the line x equals 5. Horizontal lines are in the form y equals a number, and instead of a, I'm going to say b. And so what it does is it crosses the y-axis at b, and it is horizontal. So if I say b equals -1, then we're going to cross the B line, we cross the y-axis at -1, and you are going horizontal. So that's the horizontal line is y equals a number, and a vertical line is x equals a number. Okay, so let's do an example here. We'll graph these. So if we're going to graph y equals 3 over 2x plus 3, the first thing that you do is you graph the y-intercept. So in this case, my y-intercept is at +3. So I'm going to go up 1, 2, 3 on the y-axis, and I'm going to draw a dot. The second step is you count from y-intercept the slope. And remember, slope is rise over run. So in this case, my rise is 3 and my run is 2. So I'm going to put my pen on where my last point was in step 1, and I'm going to go a rise of 3, 1, 2, 3 up, and a run of 2, 1, 2, and I'm going to draw a dot right there. Now you always want to double check your work and make sure that if this up here is a positive slope, that you are heading in a positive direction. That's positive, that's negative. So make sure that if you have a positive slope, you are heading in a positive direction. So then your last step is to connect the dots. Okay, so we're going to connect these points here, and there we have graphed y equals 3 over 2x plus 3. Okay, now let's graph this one. So remember, our slope is -2, so m equals -2, and our point on the line is going to be, remember, it's opposite of what this is. So if it's -1, it's +1. And if it's +3, it's -3 because of what we talked about up here, where our original equation has negatives in it. So that means you have to think about what the opposite is to help you find your point. So our point is at 1, -3. So my first step is to graph the point. So my point is at 1, -3. So we're going to go 1, and then we're going to go -1, 2, 3, and there's my first point on that line. Now we're going to graph a slope of 2. So my second step is to count from the point my slope. And so we have a slope of -2. So that means it's actually -2 over 1. And so we do have a run. It's invisible. It is there. It's not a run of 0. If it was a run of 0, then that would make this a vertical line, and that's not what's going on here. So we do have a run. The run is of 1. So we're going to go -2 and over 1. And you always double check. This is going to give me a negative slope. Is that what I want? Yes, I do, because this has a negative slope there. So you're going to continue and connect the dots is my third step. And there I just graphed that line. Okay? So now let's talk about parallel and perpendicular lines and intersecting. So what happens if it's parallel? Well, if the lines are parallel, then you will have the same slope. So you'll have like y equals 5x plus 3 and y equals 5x minus 6. Notice that the slopes for both of these are the same. That means that they are parallel. We learned in our last lesson that parallel lines have equal slopes, and this is an example here. So we have the same slope, but notice their y-intercepts are different. That's because they're different lines. So same slope, but different y-intercepts. Okay, now for intersecting lines, we're going to have different slopes. So y equals 1/2 x plus 7 and y equals 3x minus 2, something like that. And once again, you look at your slopes. The slopes are different. You don't care about the y-intercepts on intersecting lines. All you care about is your points. So the points are different, therefore they are intersecting. So the different slopes. Okay, coinciding lines mean that they are the exact same line. So if we had y equals 3x minus 2 and y equals 3x minus 2, then those two lines have the same slope and the same y-intercept, which means that they are the exact same line. They coincide. They lie right on top of each other. And so those coinciding lines have the same slope and the same y-intercept. Okay?